Chapter 6, Lesson 4 is part of algebra again, and we're going to write expressions. It says here, list two headings you will use to make an outline of the lesson. And the two things that we're going to talk about are we're going to write phrases as algebraic expressions, and we talked about what algebraic expressions were yesterday. And we're going to write two-step expressions. All right, so for the real-world link, it says here, Missouri has 8 major commercial airports. California has 24 commercial airports. Okay? Now, problem one says Alabama has 4 fewer airports than Missouri. Here we want to underline the key math word, and we want to circle the operation down here that we want to use to determine how many airports are located in Alabama. So, in the problem, in the statement here, Alabama has 4 fewer airports than Missouri. What's the math word? Fewer. Okay? And fewer signifies that you're going to do what? Subtract. Very good. Here, for example 2, it says California has 3 times as many as Georgia, as many airports as Georgia. We're going to underline the key math word, and then again we're going to circle the operation you would use to find how many airports Georgia has. So here, the key words are 3 times as many, right? Now, to go backwards and figure out how many Georgia has, we have to do the opposite of what's there, okay? So 3 times as many, the opposite is division. So you know the number of airports California has. You also know that it has 3 times the number of Georgia. To undo the multiplication, you're going to use division. Is everybody clear? So the first section here, we have write phrases as algebraic expressions. To write verbal phrases as algebraic expressions, we follow these steps right here. In the second step, we are going to be defining the variable. Please make sure you understand what it means to define your variable. That means to choose a variable and decide what it represents. So the steps we're going to follow are, we're going to describe the situation. Okay, you don't have to describe it written, you just describe it to yourself so that you know what's going on. Okay, you're going to use only the most important words. Then you're going to choose a variable to represent the unknown quantity, and of course that step 2 is defining your variable. And then you're going to write your expression. You're going to translate your verbal phrase into an algebraic expression. All right, so the first example says write each phrase as an algebraic expression. So here, $8 more than Ryan earned. $8 more than Ryan earned. What's the math word that tells us an operation? More. Very good. So we know more than. So what does more than tell me I'm going to do?
More than equals.
More than means you're going to add.
Oh.
More than means you're going to add.
That's what we did, yes.
So in words it says $8 more than Ryan earned. Now we're going to define the variable. So we can say D represents the number of dollars. Okay? So D is equal to dollars. Okay? And with the way we can write that, we can just write D is equal to dollars. Okay? Now, as a model, here, D, there's Ryan's earnings, right? If we have 8 more than that, that means we're going to tag on 8 more, right? You're going to tag on some more. So here, we're tagging on 8. So here, this represents the dollars Ryan earned plus the 8 more. Is everybody clear? So, $8 more than Ryan earned is written D plus 8. So the second example says $10 less than the original price. What word tells us the math operation?
Less.
Very good. Less than. So, less than tells me that I'm going to subtract. Very good. Now, be careful here. Well, before I go to the be careful. Now let's define our variable. Okay, so it says $10 less than the original. So, or the original price. Okay? So when we define our variable here, we let P represent the original price. Okay? So P equals the original price. Now, in a model, when we put it in a model, P is the original price. Okay? Now, if we're taking $10 less, we're chopping it out, right? We're cutting it out. So here, we're going to take this part out. Got it? So, if we're taking that out, we're subtracting. So the way we write $10 less than the original price is P minus 10. Now, this is where you need to be careful. If you are adding, like we did in the first one, here, if we had D plus 8, that's what we had. Could I write 8 plus D and it be the same thing?
No. Or yes.
Yeah, because 2 plus 3 is the same thing as 3 plus 5, correct? I'm sorry, 3 plus 2. 3 plus 2. 2 plus 3. Yes, it is. So 2 plus 3, 2 plus 3 is the same thing as 3 plus 2. The same thing. They both equal 5, right? Okay, but, hold on, but here, can I reverse subtraction?
No.
You cannot reverse subtraction because here, let's say we had 5 minus 2. 5 minus 2 is equal to 3, right? If I had 2 minus 3, I'm sorry. I did it again. 2 minus 5, that's going to be a negative 3. So that's two different, so you cannot switch around subtraction, okay? So for the example 3, it says 4 times the number of gallons. What's the word that tells me the operation?
Yeah. What?
What's the word that tells me the operation?
Multiply.
Times. Very good. Times. 4 times. And what am I going to multiply times? How many times it's going to be getting multiplied 4 times, right?
Yeah.
So now we want to define the variable. So here we're going to let the number of gallons, that's what we're trying to find out because we don't know how many gallons, right? G is going to be the number of gallons. Okay? So here in the model, there's my gallon, right? And we have 4 times that much. So there's 4 G's in there, right? So there's 4 G's in there. So the expression is 4G. So for the next one, we're going to do our got it problems. It says 4 fewer points than the Bulls scored. So what word tells me the operation?
Fewer.
Fewer. Very good. How many fewer?
4.
4 fewer, right? So what does fewer mean that we're going to do?
Divide.
Subtract. Fewer means we're going to subtract. So, all right. So, first thing we want to do is define our variable, okay? So, 4 fewer points than the Bulls scored. Okay, so what are we trying to figure out? How many what? How many points, right? So we can say that P is equal to points.
Wait, hold on.
Okay, so 4 fewer than P, right? So how do I write 4 fewer than P? P minus 4. minus 4. And there's your expression. The next one said 12 times the number of feet. Okay? 12 times the number of feet. So here, what is the word that tells us our operation?
Times.
Times. Very good. And of course, times means
Multiply.
multiply. Good. So now we want to define our variable. Okay, so 12 times the number of feet. So what's my variable? Feet, right? I'm trying to find feet, so I'll say F for feet. So F equals feet. Okay? So now I write my expression. 12 times the number of feet. What's my expression?
12 times F.
12 times F. And the way we write that, do I use the X?
No, you
No.
No, it means 12.
12 F, right? Or you could use a dot, or you could use a parentheses, right? But here, when you're dealing with algebra, that's how you usually see it, okay? All right, letter C says the total cost of a shirt and 8 pairs of socks. So, what's the word that tells me the operation here? So, total tells me what operation?
Adding.
You're adding. Very good. So what are we adding? So the first thing we need to do is we need to define our variable, right? So the total cost of a shirt and an $8 pair of socks. So what do you want your variable to be? Very good. So because we're looking for cost, we're going to write C is equal cost. Okay? So now we're looking for the total cost of a shirt and an $8 pair of socks. So how am I going to write my expression?
C plus 8.
Very good. C plus 8. So those were one-step expressions. Very easy, right?
Yeah.
Here now we have two-step expressions. Two-step expressions. So here, two-step expressions contain two different operations. Okay? So here we want to write the phrase 5 less than 3 times a number of points, and we want to write that as an algebraic expression. Once again, 5 less than 3 times the number of points. So the first thing we need to do is we need to look at our operations in there. So what words tell me an operation? Yeah. Less. Less tells me that we're going to subtract. And times tells me we're going to multiply. Very good. So now we want to define our variable. So let's look at the sentence again. 5 less than 3 times the number of points. What do you want your variable to be? P for points. Very good. So here, that's where we define. We said P for points. And now, here we have 5 less than 3 times the number. So, when you are writing your expression with two-step expressions, pay attention. When we are looking, writing our expressions, we want to use our order of operations. So, am I going to write the subtraction first or the times first?
Times.
We're going to do the multiplication first, right? So here, 3 times the number of points, that's P 3 times, right? Now we want 5 less than that. Now we're going to subtract 5 from it, right? So once again, we're going to write 3 times the number of points first. So that's going to be 3P. Then we're going to subtract 5 from that whole chunk. And there's my minus 5. So for this example, it says, write the phrase 3 more than 4 times the cost of a pretzel as an algebraic expression. What words here tell me the operations?
More.
Okay, so more tells me that I'm going to do what?
Add.
You're going to add.
And then.
We're going to add. More tells me that we're going to add. Times tells me that we're going to multiply. So now I want to define my variable. So again, we're going to go back and we're going to read the sentence again. So, 3 more than 4 times the cost of a pretzel. What's your variable? Cost, right? The variable. So it's C for cost, right? And now we're going to write our expression using our order of operations. We do the times first, right?
Yes.
So 4 times the cost of a pretzel. How am I going to write 4 times the cost of a pretzel? 4C. And then $3 more than that.
And 3. Plus 3.
Very good. Plus 3.
Yeah.
All right, so yesterday we did percents. We found percents using the percent proportion, and today we're going to use that percent proportion to find percents that are less than 1% and percents that are greater than 100%. So, as a review of what we did yesterday, what was, you guys remember the percent proportion is the percent over 100 equals the part over the whole, or the is over the of, right? Very good. So, we're going to do the same thing. So the first thing we're going to do is we're going to change this information into our what number is question. So here, very simple, we want to know what number is 46% of 80, right? So that's what we're going to write down. So there's our question. What number is 46/100% of 80, right? So now we have to identify our part and our whole and our percent, okay? So the percent, of course, that's an easy one, right? That's the one that has the percent sign with it, right? So this is going to be, here's our percent. And what is our part? Of 80. Very good. So of 80, oh no, I'm sorry, that's not the part, that's the whole. That's the whole. This is the whole. Right? This is the percent. Okay? And then the what number is the part. Very good. So this is the part. Is everybody clear?
Yes.
When we're writing fractions, where does the part go? On the top or the bottom? In the top. And the whole goes on the bottom. Very good. So now we're going to set up our proportion. So now we're going to set up our percent proportion. So the percent goes over 100. So that's 0.46 over 100 is equal to the part, which we don't know what it is, so that's going to be the x, over the whole, which is 80. Very good. So now we can cross multiply. Okay? So on one side, we have 100 times x, which is 100x. Good. We're going to write 100x, which means 100 times x, right? And that's equal to On the other side, let me use red. What are we going to multiply on the other side?
0.46 times 80.
Very good. We're going to multiply 0.46 times 80. All right, so we're going to multiply 80 times 0.46, and we end up with 36.8, right? And we can go ahead, and like you were saying, now we can leave off that 0, right? So, over here, we have 100x is equal to 36.8. 36 and 8/10. Okay? So now we want to divide by 100. What did we say yesterday about dividing by 100? What's that shortcut I told you? What do you have to do? No, not take away the zeros. Just what? Move the decimal. How many places? 2 places to the left. Very good. So, here, when we divide by 100, I'm going to show, we have to show that we're dividing by 100. So you show that you're dividing by 100 on this side, and show that you're dividing by 100 on that side. So now, the 100s over here cancel to ones, right? Those cancel to ones. And now I can move this decimal 2 places to the left. So 2 places to the left, that tells me that x is equal to what? The decimal is now over here. 368 thousandths. Very good. So it's 0.368.
Thank you.
So for number 8 here, the first thing we want to do is write our what number is question. So just like you said, what number is? What number is 222% of 65? So the first thing we want to do is identify our percent. What's our percent? 222%. That is our percent. Okay? What is our part? The what number, right? And that's going to be our variable. That's going to be the variable because it's the is number, right? You see where it says is over here? That's going to be, that's our part. The is, you see what it says right here? Is the part, right? That's what we're solving for. That's going to be our x. Is everybody with me? All right. And then finally, we're going to identify our of number, which is the 55, which is the whole. Very good. So here is the whole. Okay, so our percent proportion is the percent over 100, which is over, good, and that's equal to the x, which is the is, or the part, over the of, or the whole, which is, very good. Now, how do I solve this proportion? Cross multiply. Very good. So, we're going to cross multiply. We're going to go this way, and we're going to go that way. So, on one side, we have x times 100, which is 100x. Very good. Very good. On the other side, we have 222 times 55. We've got 100x is equal to 12,210. Now, how am I going to get the x by itself? Divide by 100. Very good. So we're going to divide by 100 here and over there. On this side with the x, what can happen to those hundreds? They cancel out. Well, we take everything out, right? And then they cancel to ones. And 1 times x is x. Very good. So there's x right there. And then on the other side, we're going to divide by 100. But what's the trick? Move the decimal 2 times to the left. So right now, if there's no decimal, it's in the whole number. Where is it? At the end. Very good. Good question. So now we're going to move 2 places to the left. Right? So my final answer, point. Can I leave that last 0 off?
Yeah.
So point 1.